Hi friends, greetings, and please, in this video I want us to make some corrections in the previous projected motions we did. Some errors were being made. I want us to use this video to correct them. So please, if you're new to our channel, please just subscribe to the channel and like this video, because that motivates me a lot to produce more content. Like the video because it's so important to me. You won't know how important it is, but it's so important to me. And thank you very much for watching the video, and stay tuned because we are going to be highlighting all the errors. So now let's get started. So in this case now, I said if we want to get the time taken for this projectile to leave its initial position and reaches its final position, it depends on two things. One, the launch, that is h, and the vertical components of its velocity. Keep in mind that gravity is acting where downward, of which the initial launched velocity was where upward, because this component that helps it to attain this height is upward. So the velocity vector and the acceleration vector are in opposite senses. That's why the acceleration takes a negative value. So if I multiply all through in this case now, I'm going to have my negative 2h here. Oh my god, this is where I made the error, which is the same as what? U as 2u sine alpha t minus gt squared. Great. That therefore means that I'm going to arrange it like a quadratic. I'm going to bring everything to the other side. Therefore means I'm going to have my gt squared. I'm going to have my gt squared minus 2u sine of alpha t minus 2h. That has to give me 0. Good. So in this case now, I'm going to use the quadratic formula to solve. I'll just say t is equal to, I believe that all of us know the quadratic formula, right? Great. So we are just going to apply it. T is equal to negative b. What is my b in this case? My b is negative 2u sine alpha. So it's going to be negative, which is positive. So it's going to be 2u. Oh, this guy prints a lot. This guy prints a lot. So let me just see if I can change that. 2u sine of, this one still prints a lot. Let's see if we can use this. 2u sine of alpha plus or minus the square root of, now let's do this in our head, u squared, which is what? 4, right? Which is going to be 4 u squared sine squared alpha minus 4ac minus 4a, which is gc. The minus 2h makes the initial minus to become what? Positive. Then 2 times 2 gives us what? 4. So this is going to be plus 8 gh. Great. 8gh. All that is on 2a, which is 2g. That implies now my t turns out to be, now I'm going to factor out a 4 inside here, and the 4 comes out as 2 and cancel all of these 2's I have. So I'm now just going to have my t to be equal to, and I'm going to have 2 values of t in this case. One must be negative and one must be positive. So I will choose the one that is positive. So I'm going to have my t to be equal to u sine of alpha plus the square root of u squared sine squared of alpha plus 2gh. Great. 2gh. All that on g. So please, this is the time, okay? This is the time. The previous one I did, there was no 2 here. So please just make that correction. Just make the correction. Okay, and let's get the velocity with which it is going to hit the ground with. Let's get the velocity. Like I said, we could use conservation of energy, and we could also use the other fact I listed. But in this case now, you should also see that the velocity with which it hits the ground depends on what? It depends on the time taken for the projectile to leave its initial point to its final point. So we are going to use the equation v equal to what? U plus at, where v is the final velocity, u is the initial velocity, a is the acceleration, and the t is the time taken for it to reach. So, and I know that this time has a value what? U sine theta, that, right? That therefore implies that I'm trying to get the final velocity or the velocity of impact. That therefore implies v Vy specifically is going to what? U. What is U? U is what? My UI, which is U sine alpha. What then is my G? My G is negative, right? Minus GT. Good. So my Vy is equal to what? U sine of alpha minus GT. Keep in mind that your T is what you have here. Everything here is your T. So this is your Vy. Then your Vx is constant. Your Vx, as you guys all know, it is constant. It is U cos alpha. It does not change throughout the trajectory. It does not change. Okay. Yes, your Ux does not change. So to get the final velocity now, it is going to be the square root of Vy squared and Vx squared. Great. So thank you guys for watching the video, and please, if you discover any errors in the videos, please just leave in the comment section and I'm going to correct them. Okay, thank you so much for watching, and please subscribe to the channel.